data access and storage. So the tabular model is an in-memory solution. So all the data, instead of being stored on disk, is built into memory. So nowadays you can get memory fairly cheaply, so it's not uncommon to hear boxes or servers with 128 gig of RAM, 96 gig of RAM, and so on. And if your cube is less than that, then typically you could probably build a tabular model which is all in memory, and you don't need to worry about storage, potentially. You've got the massive compression that we mentioned earlier, typically up to 10 times compression. Whereas with MoLAP, everything is on disk, although there is, if you compare relational database sizes with OLAP sizes, you will find that there is a typical compression that happens with MoLAP, around three times the relational size. Vertipack will do memory scans. It will go directly to memory. It won't even think about going to disk. You literally have to do no tuning, and that's what I found. You don't need to worry about creating aggregations or anything like that, or super optimized queries. It's all in memory and it's rapid, and any query combination, well, most query combination I should say, just comes back in seconds. Whereas with MoLAP there is room for going wrong. If you write the wrong query, you need to consider aggregation design and strategy and so on. With the tabular model, if you don't want it to be in memory, you can use this feature called Direct Query, which actually takes the DAX queries that you've created and translates them into the queries that hit the back-end databases that you've used to build your model. So the data is not pulled across into your model and stored in memory. The query goes and hits the source systems directly to get the data from there. And that's the equivalent to ROLAP that you get with the more traditional MoLAP, OLAP systems. So instead of processing the data into your cube, your queries go directly to the relational layer to get the data. The direct query is the answer to ROLAP when looking at the tabular model. Okay, let's just have a very quick demo of what some of the query performance benefits that I've seen. Okay, so what I've got here is we've got an internal cube here, and I've written this query, and what you can see is that we're selecting a few measures on our columns, and we're doing this very dirty cross join across these 3 dimensions. You can see that I've put some sizes there, so it's 10,000 members there, there's 150,000 members there, 40,000 members there. If you do the math, it's a big number. So this query here, so I've got the equivalent query here, and this is what we're looking at here is a query that's on top of the tabular model. So you can see I've got model there, and this query here, which is on top of a more traditional MoLAP cube. So just to make sure I'm not cheating, I'm just going to clear the caches of both for the tabular and the MoLAP structure. I'm going to fire off the MoLAP query first. Off it goes. Now, I'm not really going to sit around for this because this is going to run for another hour, and it's not even going to finish after that hour. What's going to happen is this is quite a beefy box. It has around 96 gig of RAM, I believe. This is going to use up all of that memory, and then it will time out after an hour. So I'm going to stop that. and I'm going to run the equivalent query. And this is again this is the MDX equivalent. I'm going to run it against a tabular model. And there we go. So within 14 seconds, I got my result set back. That's a massive performance gain. And I didn't optimize the query. I mean, there's plenty of room for optimization there, but I did not bother doing that. It's exactly the same query. All I've done now is just I've got an equivalent tabular model of that MOLAP structure, and I've run the query. And you can see straight away, 14 seconds. So 1 hour and get no result, 14 seconds and I've got my result. So you can see straight away the querying benefits that you get from in-memory tabular model. Okay. All right, so just a quick summary of the BI semantic model. Flexibility, richness, scalability. We talked about the flexibility that you've now got the ability to build traditional multidimensional models, and if you see fit, you can have tabular models as well. So based on your requirement, based on the size, based on the volumes and the frequency of change, you've got the option to go either way. You've got MDX and DAX to build your business logic and queries. You've got an equivalent to ROLAP, indirect query, and you've got a whole host of BI tools to use to query these models. And you can see there the points regarding richness. In terms of scalability, again, the amount of storage required is significantly less, especially if it's a tabular model, because it is in memory. The compression rates up to 10 times potentially, and you can still see that in terms of scaling for large applications, you've got the flexibility of the MOLAP structure still being there and the tabular model for the smaller cubes, if you like, and sort of a migration path. You know, there's nothing to say that you start off with a tabular model and then move into a MOLAP structure once you start scaling out. Because there will come a point, I mean, from what my experience, that although the querying times are very quick, some of the processing time for tabular models is greater than MOLAP structures. So that's one thing to keep in mind. Okay, some of the key points to take away then. If there's anything you're going to take away, maybe just this last slide will summarize those points. Column store indexes, data warehouse query execution acceleration. It is optimized for data warehouse queries, not transactional databases. Not only is it going to benefit the queries that you write off of these star schemas, but you can aid, you can see help with reporting and with OLAP processing, and of course ROLAP as well is now suddenly a much more attractive option for you. There's nothing new to learn. It's just like creating another index. You can see the total cost of ownership reducing because there's less DBA time being spent. You create this index and you can be fairly confident that it will answer most of your queries, and there's less maintenance required. It is just the first version. There are some restrictions which we talked about, but these are things that Microsoft are looking at, and hopefully based on some of the feedback that they find on the field, they'll be prioritizing some of those to make sure that in the following releases, those restrictions have been overcome. And I guess one of the key things to remember is to get the most out of column store index, you need to be writing queries that will hit the index and execute in batch mode. In terms of the business intelligence semantic model, you've got this new modeling component, which is the tabular model, which is all in memory, and you can see from the querying that it's rapid and it will deliver. It doesn't necessarily mean it's the death of MOLAP. You just need to know when to use tabular and when to use MOLAP structures. And with column stores indexes, rollup is suddenly now a much more attractive option because you are now querying off the relational layer which has these column store indexes, so you can experience faster querying times. So hopefully those are some of the key points that you can take away from this webinar. Right, well, thank you very much for joining me and joining all of us for part 2 of the SQL Server 2012 webinar series. Again, please email events@imgroup.com with any questions or requests for follow-up, and we hope you can join us for the rest of the series. Thank you very much. Goodbye.